Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some sound effects for our game. Okay, so previously we already added some really nice music, now let's add a whole bunch of sound effects. In the project files, if we go inside the assets over here, we've got all kinds of sound effects. Basically I hired a really nice sound designer to make all of these, and I think they all sound really great, so let's add them to our game. Now when it comes to sound effects, there are two main ways to play a sound. One is just like we did for the music, so we can create a game object, add the audio source component and play it. That's one approach, but that basically requires pre-preparing the sound objects. So there is another simpler way that just requires one line of code. So let's begin by making a sound manager game object, so a new empty game object for the sound manager. Let's reset the transform. Now let's make our script, so let's go in the scripts folder, create a brand new C# script for the sound manager. Let's attach the script and open. Okay, so now here let's make a function to play simple sound. So let's do a private void, just call it play sound. And over here the way we play sound through code is actually super simple. We just go inside the audio source class, and in here there's a static function play clip at point. This, as you can see, takes an audio clip, a vector3 for the position, and finally a volume. So basically it won't play that sound on that position. By default Unity already has 3D sound, so if you play the sound on the left or the right side of the camera, it won't play in the correct place. Also for the volume, the further away it is from the camera, the lower it will be. And if we don't want the 3D sound, we can just play directly on top of the camera position. Okay, so in this function, let's receive our arguments. So for the audio clip, it's going to be our audio clip. Then let's receive vector3 for the position. And let's also receive an optional one for the volume. Let's just default this to 1f. Okay, so here we just pass this into our function, so the position and the volume. Okay, great. So now let's call this nice function. And for example, let's start with a simple one. So let's start with the delivery sounds. So over here on the delivery manager script, down here we have the logic for delivering a recipe. And over here we know when we completed a successful recipe or when we failed and the player delivered a wrong recipe. So this is where we want to play some sounds. And again, here we have yet another very important clean code question. We could technically call the play sound function directly from here. That would work, but of course that would make this class tightly coupled with the sound manager. For a simple game on this scale, that approach can work, just play sounds directly from the logic code. However, again, to make things properly, we should really separate the logic from the sound, just like we separated the logic from the visuals. So instead, let's not call the sound directly from here. Instead, let's make two more events. So let's make one on recipe success, and another one on recipe failed. Okay, so now let's fire off these events. So over here we have the success, so on recipe success. And if we get down here, then we have a fail. So on recipe failed. Okay, great, we have two events. Now back here on the sound manager, we can just listen to those. So let's do a start, go into the delivery manager, access the instance, and listen to the on success and on failed events. So listen to that one, delivery manager, instance, on recipe failed. Listen to both of these. Again, let's write some good clean code. So let's rename this one instead of instance. Let's put it delivery manager. And same thing on this one. Also name it correctly, delivery manager. Okay, great. So now when you have this, we want to call play sound. And now I want to pass in a reference to the recipe failed sound. So technically one approach would be up here to add a serialized field for an audio clip. That would work. But since we've already done that so many times in this course, here let's use a different approach that I also like to use. Let's create a scriptable object to hold a reference to all of our sounds. So similar to how we define the scriptable object to hold all of our recipes. Let's just comment this out just to make sure the code compiles. Okay, great. So back here in the editor, let's make a new scriptable object type. So let's create a brand new C# script for the audio clip refs scriptable object. Now here let's make this a simple scriptable object with a create asset menu. Okay, so now for the fields, if we look in the S over here, the audio designer that I hired actually made several variations for each sound. So we've got multiple chops, multiple delivery fails, and so on. So back in the code here, instead of storing a reference for a single audio clip, let's store an array for all of them. So we have the chop, then we have all the others, so let's just add all of the references. So there's a chop, there's the delivery fail, then we have delivery success, then we have footsteps, then the object drop, then the object pickup, Then we have the stove sizzle, although this one is just one. Then we have the trash, and finally we have the warning. Alright, so these are all of the sound references we're going to use. Back in the editor, let's just create the object. So on the scriptable objects, let's create a brand new one. Let's make it of audio clip refs SO. Just name it audio clip refs SO. And over here, let's just drag the references. So let's use that quick Unity tip in order to unlock the inspector. Now I can select all the chops and drag them. All delivery fails, drag them. Delivery success, drag it. Then for all of the footsteps, after that are all of the object drops. Then the pickups. Then we have the sizzle, which is just one. Finally, we have the trash and the warning. Okay, those are all the references. So our scriptable object now has all of the data we need. Let's unlock the inspector, okay? And back in the code here on the sound manager, let's make another version of this function. So let's make one play sound, except instead of receiving an audio clip, it receives an array of audio clips. Then basically we just call the other function. So we call the other play sound function and pass in an audio clip from this array. So let's actually rename this. So audio clip array. And let's pass in an audio clip from here. So do a simple random.range between 0 and the array.length. Pass in the position and the volume. Okay, so just like this, now all we need is a reference to our scriptable object. So a serialized field, private, of the audio clip refs SO. Okay, we have this. Then here in the editor, let's just assign the reference, so the audio clip refs. Okay, great. And over here, when we have the recipe failed, let's go into the audio clip refs. And let's pick up, this one is delivery fail. And then the other one is going to be delivery success. For the position, let's just default to the camera.main transform.position. So like this, the sounds will play exactly on top of the camera. Okay, so let's test and see if it all works. Okay, so here we are, and let's do a wrong delivery. Now, quick warning if you're following along, or if you're just watching the video, this sound will probably be way too loud, but let's test. So if I just pick up the plate and I just deliver an empty plate, yep, there you go, there's the sound. And now if I deliver a correct one, so someone wants a salad, so let's cut a nice salad, chop that, chop this, pick up the plate, pick up that one and that one, deliver the correct salad, and yep, there you go, it does work. Alright, great. So the sound effects work, they played perfectly, but they're a bit too loud. Basically that's because these sounds were designed to be played in the world rather than on top of the camera. So when we play the sound, let's actually play it on the position of the delivery counter. Here is the delivery counter script. And based on our design, we're only going to have a single delivery counter, so we can just make this a singleton. So as usual, public static of type delivery counter, call it instance, with a public get and a private set. Then on private void awake, let's just set the instance equals this. Okay, so now over here on the sound manager, we can just grab delivery counter, and we just go in delivery counter and grab the static instance. And then for the sound position, we can just go in delivery counter, access the transform.position. Okay, so just like this on that one and on this one. Okay, so let's test. Now it shouldn't be as loud. Okay, so here we are, and let's do a wrong delivery. And yep, it does work. Now let's do a successful delivery. So let's make a nice cheeseburger. So grab some cheese, slice it, grab a plate, just need some bread, and deliver it. And yep, there you go, it worked. Alright, awesome. Okay, so this is really it. This is how we're going to play our simple sounds. Now there are some that are going to require more logic, like the footstep sounds and the stove sizzle, but first let's begin by adding the simple ones. So let's begin with the chop sounds. This is super simple. We just need to go over here onto the cutting counter, and actually we already have the onCut event that we made previously. This was used to spawn the visual, so we can also use it to spawn the sounds. However, there's actually one difference. We're going to have multiple cutting counters, and this one, as you can see, this one is not a static event, meaning each different counter is going to have each list of listeners, and we really don't want to have to subscribe to every single one of the counters individually. So what we can do is, instead of making it a regular event that belongs to each instance of a cutting counter, we can make a static event which will belong to the entire class. But we still want to leave this one just for the visual, so let's do another one, a public static event, event handler, and let's call it on any cut. Basically, for any static events that belong to any object type, I like to add the keyword any. We're going to fire this event when any cutting counter is going to trigger a cut action. So where we fire this event is exactly the same thing. So over here we've got the onCut. Let's do the exact same thing. So on any cut with this, an event args.empty. Okay, so we have our nice static event. Now over here on the sound manager, let's listen to it. So let's go into the cutting counter. Again, we're going to access through the class name, and let's listen to the on any cut event. And over here, let's just play the sound. So let's play the sound. Let's go inside the audio clip ref SSO, and let's grab the chop sound. Then for the position, we want to know who fired this event, and by following the C# standard, over here we already have the object sender. So we know this was the object that fired this event, and we know this is going to be of type cutting counter, so we can just get cutting counter, and we just grab the sender as a cutting counter. Okay, so we have this, and then over here, very simple, access transform dot position. Okay, that's it, great. That will play the cutting sound on that position on that cutting counter. Okay, great. Now let's handle the player picking up something, and for that, let's go over here onto the player class. And the way we set up the kitchen object parent system is actually already perfect for this. Down here we have a function, so if we scroll down, yep, this function, set kitchen object. This one is called whenever the player receives a kitchen object, which means really when the player picks up something. So if this kitchen object is not null, then that means the player picked up something, so let's do that. So up here, let's make the event. So a public event handler, call it on picked something. And then down here, just do a test, so if the kitchen object is not null, so if the player did pick up something, then let's just fire off this event. So just do our usual invoke with this and event args.empty. Okay, so that's great. Then on the sound manager, let's just listen to it. So let's go into the player class, let's access the static instance, and let's listen to the on picked up something event. And again, let's rename this to a proper name, so player on picked something. And over here, let's just play the sound. And for the sound, go into the refs and grab, in this case, the object pickup. And for the position, let's just go player.instance and grab the transform.position. Okay, that's it. Next for item dropping. Now we can only drop items on a counter. So over here we have the base counter class. And again, we have the same thing. So we have the set kitchen object. And again, the same thing as with the cutting counter. We don't want to be required to listen to every single counter. We just want to listen to one event. So let's make it up here. So a public static event of type event handler. And let's name it on any object placed here. And then down here, when we have the set kitchen object, we do the usual if kitchen object is not null. If so, then let's fire off this event. Okay, great. And on the sound manager, let's listen. So go into the base counter on any object placed here. When that happens, play the sound. And let's go into the audio clip refs. And this one is the object drop, so that one. And for the position, let's do the same thing we did. So we cast the base counter equals the sender as a base counter. And then we go into the base counter and let's grab the transform.position. Okay, so we just need one more special counter type. Here we have the trash counter. And this one, it never really changes the parent, it just destroys the object. So over here on the trash counter itself, let's fire off an event. But again, let's make it static, even though we're only going to have one trash, but make it static just to be able to support multiple. So public static event handler on any object trashed. And then over here, just fire off this event. So invoke with this and event args.empty, okay. So now if we go into the sound manager, and over here, once again, the trash counter on any, not the on any object placed, but on any object trashed. And on this one, let's do pretty much exactly the same thing. So let's copy this. The sound is going to be the trash sound. Instead of a base counter, we could just cast it to a base counter, but let's make it proper. So let's make a trash counter as a trash counter, and this is a trash counter. Okay, great, that's it. So these are all of our basic simple sounds. As you can see, all the logic is super simple. So let's test and see if it all works. Okay, so first of all, let's pick up an object. So if I go into a container and I pick it up, and yep, there you go, there's the sound. Now if I drop it somewhere, and yep, there's the sound. Now for the trash, pick it up, drop it on the trash, and yep, there's the trash sound. Okay, great. Then also let's check out the cutting. So if I pick up some cheese, drop it there, and cut, and there you go, got a really nice cutting sound. Okay, so far so good. Now let's handle the more complex ones, starting off with the stove. For this one, the sound is meant to be looping, but only when the stove is on, so we don't want to just play once, but play and stop playing depending on the state of the stove. So for this one, instead of spawning the sound through code, let's actually spawn it on the object itself. So let's go inside the stove object, let's go on the stove counter and open up the prefab. And inside this prefab, let's create a brand new empty game object, name it sound. Let's reset transform, make sure it's on 000. Okay, great. Now let's add an audio source component. And for the audio clip, let's use the pan sizzle. Let's make sure to not toggle play on awake, but we do want it to loop. And let's also make it a 3D sound. Okay, so that's the basic setup. Now to control this, let's make a script. So let's go into our scripts folder and let's create a brand new C# script. Call it the stove counter sound. Let's attach the script over here and let's open it. So now here first let's grab the audio source component. So we've got a private audio source for the audio source and just go on awake and audio source equals get component of type audio source. Okay. Then we're also going to need a reference to the stove counter. So let's add up here a serialized field private of type stove counter for the stove counter. Then back in the editor, let's drag that reference. All right. Now on the stove counter, over here we already have the states and we have the onState change event. Again, the same one that we used to modify the visual. So on the sound, let's do pretty much exactly the same thing. Over here, let's do a private void start. And on start, let's go into the stove counter and listen to the onState changed event. And basically, when this changes, we want to check if it's frying or fried. If so, then we want to play the sound. If no, then we don't want to play it. So let's define a bool, call it play sound, and we're going to play if the state equals we are frying or the state equals that it is currently fried and about to burn. Okay, then if we have a play sound, then let's go into the audio source and call play. And if not, then let's go into audio source and call pause. All right, so that's it, pretty simple. Let's just make sure to save our prefab, go back outside, and let's start on play. And okay, for stars, there's no sound playing. Now if I pick up some meat and I drop it on there, and if there you go, there's the sizzling sound and continues going, and now it is still sizzling, but if it burns, it should stop. So if I go, and if there you go, the sizzling sound stopped. All right, awesome. So let's take this one out. Let's actually trash it. Now let's pick up another one, let it cook. And once it's cooked, pick it up, and there you go, the sound does stop. All right, awesome. So we just have one more final sound remaining, that's the footsteps. By the way, the warning sound is going to be added during the polished lecture. For the footsteps, we want very much the same thing that we did on the stove. So we're going to want a script to handle that logic. But this time we don't need an audio source on the player, we're going to use the same play method as the other ones. Let's just make a script to run the sounds, so let's make a new C# script for the player sounds. Let's go into the player game object and attach the sound, okay. So now here let's first grab the player reference. So private player, and on private void awake, let's get the component of type player and assign it to the player, okay. Then for the footsteps, basically we want to play them every certain amount of time. So let's do up here a private float for the footstep timer, another one for the footstep timer max, and let's say we want to play, say, 10 times per second. Then we do a basic update, and on update, footstep timer, countdown by time.time, and if the footstep timer is under 0, then let's reset it, so set it to the maximum, and it's in here that we're going to play the sound. So now here we have two options. We can fire an event here, and we can listen to it on the sound manager, so exactly the same thing that we've been doing previously, or we can just trigger the sound directly from here. Doing that will mean that this class is tightly coupled with the sound manager. Usually we want to avoid tight couplings. However, in this case, the player sounds class, this one is really only meant to exist alongside the sound manager. So in this case, it's perfectly fine to tightly couple them. So let's play the sound directly from here, which means we need a reference to the sound manager. We could make a serialized field or just make this a singleton, so let's do that. So a public static type sound manager. Name it instance with a public get and a private set. Then on private void awake, we just set the instance equals this, okay? So then over here we can just access it. So just go into the sound manager, access the instance, and we call play sound, which we actually need to make public. However, this function also takes a reference to the audio clip array. So that means we need a reference to the audio clips. So again, we have multiple options. We could add over here on the player sounds, add a serialized field for the footstep sounds, or we can just make a specialized function over here on the sound manager. Both options can work just fine. Let's go with the second one just to be different. So just make here a public void play footstep sound. We're just going to receive a vector 3 for the position, and then we just call play sound. Let's go into the audio clip ref.so, and let's pick up the footsteps and play it on this position. And let's also receive the volume. Just up here a float for the volume. Okay, so that's great. Now we just need to call this function. So over here on the player, instead of calling play sound, let's call the other one play the footstep sound. Then for the position, that's the player transform.position. And for the volume, I just exposed the volume just in case you want to make the footsteps a bit more silent or not. But for now, let's begin with 1F and then see if that's way too loud. As usual, instead of using magic numbers, let's define a float for the volume, put it at 1F, and over here use the volume. Okay, great. However, you might be noticing an obvious issue here. Right now, this is going to play non-stop. Obviously, we don't want to do that. We only want to play footstep sounds if the player is actually moving. So this is pretty simple. We just need to ask the player if it is moving. And we already did that, so player is walking. So if the player is walking, then we play the sounds. If not, we don't. Okay, that's it, so let's test. So here we are, and if I'm standing still, there's no footsteps. Okay, that's great. And as soon as I move, yep, there you go, we got some nice footstep sounds. Alright, great. So with all of that, we added all of our sounds. Now here, note how we mostly use this method of going into the audio source and using the play clip at point function. This one is great because it is so simple, but it does have limitations, specifically with regards to all of the options. If we look on the audio source component, here we have all these options, so you can use an output, use an audio mixer like we saw in the previous lecture. We can play around priority, play around the pitch, make it 2D or 3D, play around over here with how the sound falls off. So tons and tons of options that you can't really access if you use that simple function. So one approach, if you needed these options, you could make each sound a prefab, so make a prefab for each different audio clip, and then instead of calling that function, you would simply instantiate that prefab to spawn that audio. So you've got lots of options depending on how complex you want your sound to be. But for a simple game and for simple sounds, this one line of code is super simple. Alright, so here we have added sound effects to our game. That coupled with the music that we added previously already makes everything sound so much more alive. It's really starting to look like a proper game. The one thing we still don't have is some kind of game start and game end scenario, so let's add that in the next lecture.